I think that this will also help reiterate everything that I've gone over so far. So this is, I'm going to create a data frame with cbind and rbind. I'm going to go back into the PowerPoint. So now that we've covered factors, I went through, this will make sense why I did this in this order. Order was what I struggled with today because everything builds on everything else. So column binding, we went over this for just a real quick minute earlier for an example. But binding columns, what does that mean? You can bind or combine together two data frames with the same number of rows into one data frame. That's something you can do with cbind or column bind. The same can be done with vectors if they have the same length. And that's what I showed earlier today. And that's what I'm going to show now. So you can combine vectors to make them two vectors a data frame. You could combine a data frame with 5 rows. You could add another column with that cbind, as long as the vector has, if it has 5 rows in the data frame, the vector would have to be a length of 5 to do that. But you can combine data frames and vectors with this cbind value, and you can actually create a data frame with vectors using cbind, which is what I showed earlier. This is going to be a more thorough example. So say, for instance, you were given data, and in reality, when you are working with data, it's going to be a lot bigger than this. Just, I want to use a very simple example so you guys can get the hang of this. But say in reality, you were sent in a CSV file the data for men and the data for women. In this case, I'm going to do some type of test at the accuracy of some medical test, for instance. So we have these values here. So in this case, I'm going to show it with vectors, just so I can demonstrate how vectors can be changed into a data frame. So like seen earlier, female.names, we're setting these to mean 3 different women: Erin, Alexa, Joyce, and Lauren. We have our female accuracy numbers. So for Erin, it was 0.9. For Alexa, it was 0.6, so on and so forth. So I can create with these 2 vectors a data frame, and we've seen that already. So to do that, we would put in the cbind function the female names, comma, and the female accuracy, and then we would wrap that in a data frame, the data frame function. So I'm going to go in here. It's exactly what we're seeing here. So say I got data for men separately. Like I said, in real life, this would probably be a CSV file that is much larger. But for demonstration purposes, I'm doing it as a small example. So we have Mike, and Mike is referred to as 0.55. Erin is 0.95, so on and so forth. So we have 2 more vectors there. So this is what I just showed in the slide. We're taking our female data. We are putting it inside cbind, and which is then inside the data frame. So we have our female data. I'm going to open that. So now we're seeing something that looks like a data frame. And then you'll notice that female names then becomes your column name, and female accuracy then becomes your column name here. So keep that in mind when you're creating data frames. So we are.
Can I ask a question?
Mm-hmm.
The reason that you couldn't use the factor with the column variable is because the data frame didn't exist yet. Yeah, that you're actually building it out of the vectors.
Yes, and something that I'm going to show and demonstrate here, you always, when you create a data frame, when you create any type of data frame, you always want to check the column types when you create it. I showed up here, up at the top, I put strings as factors equals false into this data frame because there are default types that this function makes your it converts your, and they might not always make complete sense, so, or intuitive sense. And this is something that, and I'm going to show why this matters in a little bit, but these as is are a character variable and a numeric variable. This would be character, this would be numeric, but this data frame function automatically changes everything to factors. Why? It's just the function. It's actually really annoying, and I've always hated it. But you'll see here, you see the default, you're seeing strings as factors. If you look down here, strings as factors, the default is strings as factors. I am actually, yeah, the default is true. So strings as factors, it's defaulting all of your string variables to factor variables when you create a data frame. So keep that in mind. And now we create that data frame. We'll do the same for men. And that'll make more sense in just a minute. So I'm going to open this, see this here. See, now all of our variables, because we didn't specify strings as factors equals false, both of them are now factor variables, which we might not want. I'm going to keep them as is. I'll show you how to make this not happen below in just a minute, but I'm going to keep it. So that's just the default for our function here. It's just what it does. And then you would have to check the help file to find those defaults. I'm going to next show, and I'm going to go right back in here. There's something that is, I'm going to skip here real quick, that is called a binding rows or row bind. It's the same thing as bind, it just binds the rows together. So that'll make more sense when I show what it looks like. So when we bind columns, we have to have the same number of rows because we are binding them together they have to have the same so this, we were binding these two together. If we had 5 values here and 4 values here, it wouldn't know how to bind them together. So they always have to have the same number of rows when you bind things together. When we were doing a row bind, so we are, in this case, I'm showing the example of we are taking our female data and basically sticking it on top of our male data. That's all we're doing here. So that's what we would think of as a row bind. However, as currently written, we have our female data and we have our male data. And now remember that our row names for the female data are female names. Female accuracy is our female row names. I'm going to get rid of these. If I go to male data, it's male names and male accuracy. Say I just tried to use the row bind here. The names do not match previous names. So, okay, our names don't match. That's the thing about row bind. You have to have the same names or column names for both data frames that you want to row bind. So in this case, I want to change the female names and the male names to names, and female accuracy and male accuracy to accuracy. So first, you can specify, in this case, the names data is just an object that represents these. And I have in here, show you how to use this. So we have our names.data, we have a vector with the names that we want for our data. And then we have column names. Then inside of this is a function, and you always specify the data frame within that column names function. This is the data frame that you want to change the names for. And then you can assign the names.data. So this names function will, this names.data will be the new column names for female data. So you can see what I mean by that. We created this. Now this names.data means names and accuracy. So when I look at column names, female data, it's showing female names and female accuracy. So I want to change it with our names.data. Now, when we look at column names, they are now names and accuracy. I'm going to do the same thing with our male data. So column names, male. Now that is also called names and accuracy. So now when I try this again, because they have the same column names, our bind works. So to try to demonstrate one more time. So female data, we have that here. We have our male data. So it looks very similar. It's got the same, it's got the names in the first column, the accuracy in the second column for males and females. They now have the same row names. So when we use that rbind accuracy data, all we did was plop the female data on top of the male data. So now they're in one data frame. So like I said before, and we can look in here, it's a data frame. All right, because we combine two data frames together, which means it is still a data frame. Now back to the data types. This is why I had to go through and explain factor variables right before data frames. So as I said before, the data frame function automatically changes its values to factor variables by default. That is evidenced by this. The accuracy data, it's a factor variable. Even though it has number values, it's a factor variable. And you always want to check this. Why do you want to check it? Here, this is something that I did in my first job using R. I came to my boss and she looked at my results that I gave her and she said, these make sense. These results, because she had domain knowledge and she knew what they should look like, the results that I gave her. I said, she told me that my results made no sense. There had to be an error somewhere in my data. So she's like, okay, so did you change that particular numeric value? She said, did you change that from a factor to numeric variable? And I told her, yes, I did. So as we have seen already, since these values, these numbers are a factor variable, they are stored as 4, 1, 2, 3, 5, so on and so forth. But they have the labels of 0. 0.6, 0.74, but they are stored as. So the mistake that I made when I made that error and I was getting these results is that I did this. So I assumed that when you change a variable or a variable that looks or has numbers in it that is a factor variable, I thought that you would just do it the same way that you do everything else. We would use this as numeric and to change it to a numeric variable. Well, what happens when we do that? And I think so. Sorry, it's a little slow. Recording sometimes slows it down a little bit. Okay. All right. Now our accuracy numbers, they don't look like they did before. When we use that as numeric value function, it changed it to our factor levels, which are completely meaningless. We wanted our original, like we had in male data, we want these values in there, but it changed it to our factor levels. Very easy mistake to make and one that was embarrassing for me. That's what I try to do in this class, is to teach you so you don't make these same mistakes. So what should I have done instead? So I'm going to just redo this rbind just like I did before, so it puts our data back where we were before. We fixed this by changing it to a character variable first and then changing it to a numeric variable. So accuracy. I'm going to show this step by step because I think it might. Accuracy as character. So let's run that. Now we're going into accuracy. So now our values are what we wanted, our actual accuracy. They're stored that way as well. So they're stored as 0.9, 0.6. So that's the intermediate step that we need to do before we change our factor to our numeric looking variable to a numeric variable. So we've changed that. Now they look and are stored as our accuracy values. Now, if we do the as numeric, we now, instead of having that meaningless mess, have our accuracy values in here. So that's something you have to keep in mind. If and when the difference here. So I'm going to go back into our slides.
Okay. Do you still have the levels?
No, because we got rid of those factor variables. We were changing them. So factors have levels. And then when you change it to a numeric or when you change it to a character, it is then stored differently. So if we look at here, this is our numeric variable. There's no storage number here. Like it's just the first value is stored as 0.9, the second as 0.6. There's no back end value.
So it's not a factor variable anymore. We could call it a vector variable.
A numeric variable. So that's what, when we look here, I changed it as numeric. So when you do as numeric, it changes it to a numeric variable. We first changed it to a character variable. So that is anything. Let's go back real quick.
So, and I hate to, I don't want to belabor the point, and it may be a stupid question, but it is a variable of all numeric object types.
Yes.
But that's also, by definition, I think, like transitive property, also a vector. I think.
Yes. Well,
okay.
Every column is a vector, but a vector has a type. Vector always has a type. So here, we'll swing back to this. So this is a vector, but it has numeric values only. So it's numeric. This is a vector and it has character values. That's why I skipped over this vector for a second. And then integers you're seeing here and logical. So the only difference, you can have the same values in a numeric column as in a factor column, but they're stored differently. That's what we went over before, and we can see that because this is still a factor variable. It's stored as something different than is showing up in here as if we open it. We're seeing labels here, but it's stored as a number. So for some reason, and because you can't, say I wanted to multiply these by 3 for some reason, and it was stored as a factor variable, it wouldn't let you do that. You actually wouldn't be allowed to do it because it wouldn't know just how to multiply something by 3. You can't multiply or change or do calculations on a factor variable. So that's why you would want to change it to it. That's what we're doing here. So when we're changing, and I'm going to go in here. So I went over to data types. So when we're working with, say we have a factor variable and it only has character values in it, or strings or letters, we can first jump to as character, and then if it's already a factor variable, and change the city value to a character value. What I was showing here, by the mistake that I made with my employer, my first job, numeric works a little differently because they're actually stored as numbers in the computer. So when you don't change it to a character variable first, it gets confused. It doesn't know whether to use the storage numbers or the labels. So it uses those storage numbers. However, we don't want those storage numbers because they are meaningless to us. So this is how you would change a factor variable with numeric or number values in it to a numeric variable. And this is just to try to save you guys the embarrassment that I had. Now, it's a little different, as I said, for a character variable. So accuracy is still a factor, but say we want it to be a character variable. For instance, you can't merge factor variables, they won't merge correctly. If you're trying to merge two data frames together or put them together with a with factor. So we want to change it to a character. We use that as character function. Now we go over here. Now they're stored as the actual values: Aaron, Alexa, Joyce, and Lauren. So that's was a lot of work. You may want to streamline this process. All of this code is the same as what I just showed you, but I started with strings as factors false. I added that to our data frame function here. So that takes out a lot of intermediate steps that I did. So we put our strings as factors equals false. I'm just going to run this is the same code you saw above. Now names is a character variable, not a factor variable. Now accuracy is still a character variable. I'm explain why in a second. So, but now instead of changing it from a factor to a character to a numeric, now we can just use variable. This did this in a lot less steps than our first, and it looks the same as our end product from above. The difference is I default value to not be factor variables. So that took out a lot of the work that we did. Always try to do things in as little steps as possible. Okay, so now I'm going to confuse you a little bit, but I think it is, as Michael said, it's good to understand what's happening on the back end. So you'll notice that when I just ran this code, so I did the R bind, our class for our accuracy variable is character. Why did that happen? Why didn't it change it since we did the strings as factors equals false? Why wasn't it automatically changed to a numeric variable? That would make sense. So I'm going back to our original matrix when I went over a matrix. So I'm going to go back in here. Matrix. So this matrix, and I actually defined it here. Matrix. Matrix is a rectangular array of the same type. So if they're numbers, they have to all be numbers. If are any letters at all, everything will be changed to a character variable. Whereas the data, each column can be something different. So what's going on here? That everything's being changed to a factor variable, to character variables, even though we put this. And they were originally changed to factors. All of them were changed to factors. So when we're using this cbind here, until we make it a data frame, this will be, I'm just going to do a test. When you see this blue caret, that means it's a data frame. You're not seeing that blue caret here. Matrix. So until we use this data frame function, this cbind is automatically making our data a matrix. So that explains why everything is a character variable. We can open that up. So because one of these values has a letter, all of these values are made to be character by default because it is a matrix. That is confusing, I know, but you have to understand that to realize that there needs to be a second step here. So when we have our matrix, so this is a matrix, and we're saying strings as factors equals false, this matrix it has been stored as character variables, even though accuracy are numbers, but the matrix, since it's stored as a matrix, and all has to be of one data type. So it's forcing it to be an entire a matrix of characters or letters, because it can't be both. It can only be both when we change it to a data frame, which is why we had to go through the extra step are changing our accuracy to a numeric variable from a character variable.